Hello, good day viewers. Welcome to my YouTube channel. I'm your presenter, Mr. Mlenga. So right here with me, I've got a question that came in 2017 Mathematics Paper 1 for external candidates. The question reads, the diagram below shows the speed time graph of a 100 sprinter who accelerates uniformly for 3 seconds until he reaches a speed of 12 meters per second. So here we have the speed time graph, okay, which is showing a 100-meter sprinter who accelerates uniformly for 3 seconds. So from 0 to 3, this sprinter accelerated from here and reaching the speed of 12 meters per second, okay. He maintained the speed for 7 seconds. So he maintained from here, started going this side, he maintained the speed for 7 seconds. You can see you have a 3 here and a 10. Okay, so there was the difference of 7 seconds. He maintained the speed for 7 seconds and then uniformly retards. So he started now retarding here. Okay, he started retarding or decelerating for a further 4 seconds and comes to a stop. Now let's look at the questions. So here are the questions. Question A, calculate the acceleration during the first 3 seconds. B, calculate the retardation at the end of his race. C, calculate the distance he covered in the first 10 seconds. So this is a speed time graph, okay? So we are going to start with question A. So I'll start with question A right here. So this question A, they want you to find the acceleration, okay? So when this person or this sprinter was accelerating from 0, started accelerating going upwards here, okay? So the speed here was 0, that was his initial speed. Once he started accelerating going up here, then his final speed was here at this point, okay? So we are saying acceleration will be given by this formula. Acceleration is equal to final velocity minus initial velocity over time. This is the formula. So from here, we are saying acceleration is equal to final velocity. We have said it started from here, the initial velocity, then the final velocity was 12. Okay. So where there is v, which is the final velocity, we're going to put 12 minus initial. We have said it's a 0 over. So they have said acceleration during the first 3 seconds. So you can check from 0 here to 12, then it was accelerating the first 3 seconds. So where there is time, you put a 3. All right. So when you say 12 minus 0, you get a 12. So acceleration is equal to 12 meters per second over 3. Okay. Okay. Over 3. So from here, what will be our answer? We are going to say acceleration is equal to 3a1, 3 into 12, it's a 4. So we have 4 meters per second square. So this was the acceleration. Okay, so this is the answer for question A. I hope it's clear. We are together. Now let us look at question B. Okay, so question B is saying calculate the retardation at the end of his race. Calculate the retardation at the end of his race. So now, remember, he started the retarding from this point. Okay, so he started at this point. Okay, then he was coming down all the way here until we made the stop here. Okay, so in other words, this side we call this as deceleration, which is a negative acceleration. So to find the retardation, here you just say retardation is equal to, so if you started the retarding from here coming here, it means this one at this point, this is going to be your initial. Okay, here will be your initial, then here it will be the final, not so initial, final. So the initial velocity or the initial speed, sorry, it's 12. Okay, the initial, then the final, it will be a 0. So retardation will be initial velocity minus final velocity over time. Okay, so from here, what you do is your retardation is equal to initial velocity. I've said started from here, so the initial velocity is a 12. Okay, so it will be 12 minus what will be the final velocity. So since he made the stop here, so it means the final velocity was 0 over, now 12 minus 0 over what will be our time. So let us look at the time, 14 to 10. So when it was retarding, okay, the time difference here, 14 minus 10, 14 minus 10, you get a 4. So the time here was the 4. All right. So what are we going to do? You can proceed. You say retardation is equal to 12 minus 0, you get a 12 over a 4. Okay. So from here we say retardation is equal to, so 4 here, it's a 1, 4 into 12. This will give us what? 3 meters per second square. This will be our retardation. Okay. So if they had asked you to find the acceleration, okay, at the end of the race, it will be a negative acceleration. Okay. So this is our retardation and this is our acceleration. So let us go back to our diagram. So here I've said if they have asked you to find the acceleration here at the end of the race, it would have been a negative acceleration. Okay. Now let us come to question C. Calculate the distance covered in the first 10 seconds. The distance covered in the first 10 seconds. So we are going to locate or identify where 10 seconds is. So from 0, 10 seconds is right here. Okay. So the distance that you are considering, or let me do this, the 10 seconds is right here. Okay. So let us identify the shape that we are going to have. You can check. This is the shape, not so. So this, they want to find the distance that I'll shade right here. Okay. So this is the distance they want you to find in the first 10 seconds. Now from here, there are two formulas that you can use. You can see you've got this shape, this first one, then you've got this one. So distance under a graph, okay, we just consider the area, okay, the area of the shape. So when you look at this shape, this is a trapezium, okay, so you can use the area of a trapezium as your distance, okay, or you can get this shape one by one. So you can get this triangle, the distance of this triangle plus the distance of this rectangle. So it's up to you which one you are comfortable with. So let's say we use the area of the trapezium, we treat this as a trapezium. So what are we going to do? Okay, let's see. So this is what we are going to do. Since we are saying we use this as a trapezium, so we'll do this. We'll say a distance under a trapezium is given by the formula a plus b times h over 2. This is the formula, not so. So from here, from this shape, let us identify a. It will be from here to here. Okay, this we can mark this as our a. Then b, it will be from here to here. So this will be our b. Then our height, it will be from here to here, this point. This is where h will be. Okay, so your a will be the difference in time between 10 and 3. So 10 minus 3, okay, this will be a 7. So a will be equal to 7. Then for b, it's from here to here. Okay, so 10 minus 0. So for b, it will be equal to 10. Okay, then for h, the height from here to here, this is corresponding to this velocity which is here. So the height is equal to what? 12. So knowing that, let us come back to our formula and we fuse in. Okay, so you say distance is equal to, where there is a, we put 7 plus, where there is b, we put 10, then times, where there is h, we put a 12 over, okay, over what? A 2. So from here, we say distance is equal to, so you can cancel these 2 here. 1, 2 into 12, it's a 6. Okay, so we have 7 plus 10, which will give us 17. Yeah, to give us 17. 7 plus 10, 17 times, then we have a 6 right here. Okay, so 7 times 6. All right, so our answer will say distance is equal to, so this will be a 102 meters. So this is our answer. So 17 times 6, it will give you 102 meters. Okay, so we've come to the end of our lesson. Thank you so much everyone for your time to view this content. Please don't forget to subscribe to my YouTube channel. Bye bye.